A very good afternoon to all. We'll wait for another 5 minutes for the participants to join. Thank you.
Goes to Q2. Q&A.
Sir, good afternoon, sir. Sir, your mic is muted.
Okay, hello? Hello? Hello?
Okay.
Hello, sir. You're audible, sir.
Yes, sir. No, your voice is audible.
Okay, right.
Hello?
Sir, is my voice
Sir, you're
audible?
audible, sir.
Audible,
Yeah,
sir.
I am able to hear
Okay.
you. Okay. I'm able to hear you.
Arshia ma'am, you can start.
Yes,
I'm
sir.
able to hear you.
Yeah.
Okay.
Yes. Sir, I have given you the co-host permission so
Yes,
that you
yes.
can share the screen.
Okay.
And Arshia madam, you can start the
Yes.
session.
Good afternoon, all. Honorable Principal. Good afternoon, all. Honorable Principal, Dean Academics, the renowned speaker, HODs of all the departments, my dear colleagues, and my beloved students. I, Arshia, Assistant Professor from CSE Department, feel privileged to extend my warm welcome to one and all for the 5th day of workshop on privacy and cybersecurity. Today, as many companies and organizations are moving massive amounts of data, be it highly confidential business or fairly unimportant information to the cloud, but as they do this, they realize how complicated it is protecting and securing all their data on the cloud. Companies face a host of security challenges, including the potential for security breaches, loss or theft of sensitive data, application vulnerabilities, and malware propagation. For these reasons, it's no surprise that 9 out of 10 cybersecurity professionals are concerned about cloud security. In today's session, let us enhance our knowledge on how to secure data on the cloud. I am delighted to have the gracious presence of our today's resource person. It is indeed a special privilege and a pleasure to welcome Professor S. Ramachandran sir on behalf of the organizing team of KMIT. Let me now walk through the extraordinary profile of Professor S. Ramachandran sir. Professor S. Ramachandran sir is an extremely eminent and outstanding personality in the field of education. Sir holds a PhD in computer science from Osmania University. Presently, sir is serving as a Vice Chancellor at Anurag University, Hyderabad. Sir has served the Department of Computer Science Engineering, University College of Engineering, Osmania University for a long span of over 34 years. Sir has also served as Vice Chancellor of Osmania University for 3 years. During Sir's tenure as Vice Chancellor, Osmania University attained NAC A+ grade and was conferred Category 1 autonomous status by UGC. Sir has also held several other positions in the university, including Dean Informatics, HOD CSE, Chairman Board of Studies, and most importantly, Vice Principal of University College of Engineering. Sir has even developed softwares for secure online question paper distribution and a software for web-based admissions for PG set and OU set. Sir's research areas include distributed computing, cloud computing, and cybersecurity. Sir has published about 110 research papers in various journals and conferences. Sir has even executed 3 R&D projects sponsored by UGC, Cypher Cloud, and AICT. Sir has also authored books on software engineering, operating systems. Sir is a senior member of IEEE, CSI, and ACM. Sir has bagged many highly acclaimed awards. Like Sir was awarded the Best Teacher Award by Government of Andhra Pradesh in 2013. Sir was awarded Eminent Engineering Teacher by Institution of Engineers in 2016. Sir has been awarded the Best Paper for the paper presentation at an international conference at Malaysia. Sir, we are glad to have you for today's session. Without any further delay and with due respect, I would like to hand over the session to Professor Ramachandran sir. Over to you, sir. The board is all yours. Thank you.
Thank you very much. Are you able to hear me?
Yes, sir.
Are you able to see the screen?
Yes, sir. Cloud data security. The first slide we're able to see.
Right. So the participants are basically right? Hello.
Yes, sir.
Okay. I think this is the third day or fourth day.
This is the 5th day, sir.
Yeah, okay. Okay, thank you very much for giving me this opportunity.
My pleasure, sir. My pleasure.
This will be for 1 hour, few minutes. Okay, I think sometimes lost in getting connected to the Zoom. Anyway,
Okay, sir. Not a problem.
not a problem. I'm very happy to talk to all of you. Yeah, you can ask me questions in between. Okay, this is about cloud data security. You know, we have been doing some work in this data security. That is why I've chosen this topic to share with you. This is the outline of this lecture. I will give you some introduction to cloud so that to put this problem in context, and then we'll try to understand how we can protect data, and how can we do operations on encrypted data. Also, we can do homomorphic encryption, and then some practical systems also we look at. This is the outline. Yeah, I think all of you are quite aware of these cloud computing models. I just, you know, briefly touch upon. I think all of you are aware of this delivery models of cloud. Software as a service, platform as a service, infrastructure as a service. We have been using this cloud for a decade, actually.
We have been using this cloud.
Hello? Yeah.
Sir, sorry to interrupt you,
For
sir.
a decade.
Sir, sorry to interrupt you. Actually,
Yeah, please go
Sir, if you
ahead.
could
Please go ahead.
turn off your cam, I think it will be.
What is that?
Yeah, please go ahead. Please go ahead.
Yes,
Is it
sir.
okay now? Is it okay now?
You can turn off
What is
your.
that?
Sir, you turn off your cam, sir, so that your voice will not break.
Is it okay now? Is it okay now?
Yes, sir. Now okay, sir.
Okay.
Is it fine? Hello? Hello?
Yes, sir. It's fine now, sir. Please continue, sir.
Okay, I'll opt the video. Okay.
Yes, sir.
So,
Thank you, sir.
yeah, right. Yeah. About cloud. And there are deployment models like private cloud, public cloud, hybrid private and public, and there are community clouds, all these things. Yeah. Of course, this further, if you understand, from the point of view of managing this infrastructure, then we have self-managed and third-party managed. Okay, so we can also have clouds at our own places, but they are managed by ourselves. Public clouds, if you look at Google and Amazon and then Microsoft, all of them, they provide this public cloud services, and they are managed by themselves, or we call them as third-party managed clouds. So in a way, this gives some idea of what is a cloud. So from particularly, we have to look at from the point of view of managing these clouds. These clouds are managed by third party. Okay, so that what I mean to say, Google, Microsoft, and such companies, they manage the clouds. This is in contrast to private owned IT infrastructure, where they are managed by the owner. They are managed by ourselves. So this understanding of this distinction is very, very important for our topic now. So that's why I just want to put this point in the context. Yeah, let us move on. So what are the security problems in the cloud? Most of these security problems stem from these three aspects. One is, of course, loss of control. I mean to say, once you put your data on the cloud, it looks as if we are losing the control. That means we are actually delegating the management of data to third party. So, we are losing the control. For example, Usmania University keeping the data on the cloud. The moment you put the data on the cloud, then you feel that you are losing control on your own data, right? And somebody else is gaining the control over your data. So that's a big worry, actually, from the point of view of security. I caution you that the security problems, all those security problems which exist in otherwise are also present in the cloud. But apart from that, this is another point we have to note down. So, and then the next point is lack of trust. Okay, so I mean to say, do you trust the people who are managing these clouds, who actually have access to our data? So how much you can trust them? The other one is multi-tenancy. The clouds, not only they provide service to you, they also provide service to your competitor. So because this is what we say multi-tenancy. So you are there, your competitor are there on the same cloud. So obviously this is a concern because your competitors also might look into your data. So these are the problems which are of concern from the point of view of security when actually you are keeping the data on the cloud. So these problems exist mainly in third-party management models. Just how we have understood third-party means. Okay, so all this exists in an environment where actually your data you have put on the cloud. Okay, self-managed clouds still have securities, but not related to the above. Okay, so these problems are not there if the cloud is managed by yourself. Okay, but once you are using a public cloud, then these are the issues that crop up. Okay, so you feel that you are losing the control on your own data, and how far you can trust the people who are actually managing these clouds, and also not only the cloud hosts your application, it also hosts your competitors' applications as well. Yeah, we'll keep these things in mind when actually we discuss the solution for this. Okay, I just put this slide to understand the impact of these data breaches and so on. Yeah, according to IDC, less than 5% of $27 billion spent on security products directly address data center security. So there's so much actually money spent on these security products. And according to another study, Online Trust Alliance in 2013, more than 97% incidents would have been prevented by implementing simple steps and following best practices and internal controls. And of course, there are so many attacks that are taking place. I think you must be hearing that there is heartbleed, shell shock, poodle, ransomware. All these are various attacks that are taking place, and obviously, and for the reasons which I've just not explained, so we have to be careful about using the services provided by the cloud service providers. Yeah, just try to understand if you're keeping data on the cloud. Yeah, if you want to understand from the point of view of life cycle of the data, you see that data is sometimes it is in the transition, or it is at rest, or data is in operation. Right. So data during its life cycle actually goes from one state to the other state. Okay. Sometimes data is in the transition, like in the web, okay, or in the cloud. So data is moving from your, desktop or laptop to the cloud, and vice versa. Right? That's what we say. Data in transition. Data is at rest. It's just lying on your cloud or your laptop. It is at rest. Okay. And the other thing is, of course, data is in operation. You are doing some operation on the data. Yeah. So if you can protect the data in all these phases, probably you can protect the data always. Okay. That is a point I would like to tell you. Okay. And if you look at data is always protected when it is in transition. If you are using a web, okay, the data is always protected, always encrypted, okay, while it is in the transit. And while it is in rest, you can always encrypt and keep it. And while it is in operation, we actually have to think about this. Okay, do you have any solution for this? So if you look at any language, suppose if you have written your programs in Java or for that matter in C language, all of them, they assume the data is in plain. Data is in plain. So that means even if the data is encrypted, while it is at rest, the moment you want to do operations, you have to decrypt. Okay, so because your programs, they assume the data is in plain, or your applications or programs work only on the plain data. Okay. So what is that we have to do? Okay. So yeah, what I mean to say is if you're using cloud services, so you can send data which is encrypted, because data in transition always is encrypted. You might use SSL, so on. While at rest, you can use some AES and keep data in encrypted form. But while actually you are doing operations, you have to decrypt. Once it is decrypted, the data is exposed, and then people might look at your data. This is the whole problem. Okay. So what is that we can do? As of now, actually, if you see all these applications of programming languages, they assume that the data is in plain text. Right. Yeah, while the data is in transit, we use SSL, yeah, TLS, VPN, all these are solutions. I think we are using HTTP or HTTPS. So actually they use this SSL, and then they see that data is in encrypted form while in transit. Okay. While data is at rest, you can actually do some kind of encryption, keep it. I think some of you must be doing this. Okay, to protect the data while it is at rest, we always do this. Okay, and then and obviously, if you look at from the point of view of the life cycle of the data, you see that data should be protected while in operation also, so that the data is protected always in all its states during its life cycle. A few attempts have been made to protect data during operations, and that happens to be our topic, today's topic. So let us look at this. These are the classical encryption schemes that exist now, right? And I think all of you must be familiar with this. Maybe these topics might have been already covered. Okay, I think all of you must be aware of the symmetric key encryption, right? Where a key is used for encryption as well as decryption. Okay, of course, key exchange is a major challenge. I think there are ways and means by which actually you can exchange the key. Okay. This is very effectively used in while the data is in transit or while the data is in at rest. We use some kind of symmetric key encryption for this purpose, and AES is predominantly used to encrypt the data, right? And this is called symmetric key encryption. Okay. The same key is used for both encryption as well as decryption. As I told you, AES is a big example for this. Right. And public encryption also is used. In fact, it involves two keys. One is called public key, the other one is called private key, and so on. Want to send data to your friend, you only have to have a public key of your friend. You encrypt the data using public key, and then send to your friend, and that can be decrypted only by your friend because the private key is only with your friend. Okay, so this is called public key encryption, and this is also used for various purposes. Okay. If not for encrypting the data, but it is very popular for exchanging the key itself. Okay, exchange the symmetric. There are various applications of public key. We can use for encryption and decryption. Okay. Normally, it's not used for encryption and decryption extensively because it is used non-defined. Of course, it is used for digital signatures. It is also used for key exchange. If you want to exchange the keys, then you can use public key. Okay. But both of these category of encryptions, they don't allow computational encrypted data. Okay, so that means they do not serve the purpose of protecting the data while the data is in operation. Okay, that is the point. So you can use them for encrypting while the data is in transit and while the data is at rest. Okay, so we cannot use these encryptions for the data which is in operation and still do operations. Okay. I think all of you know these two techniques. Now what we are looking at basically delegating processing of data without revealing. So what I mean to say is I want to put my data on the cloud, encrypted in the encrypted form and still do my operations. Okay. If that is ensured, I will still have the control over my data. Because as I told you in the beginning, so we are losing the control over the data that is kept on the cloud. But if we have this facility where actually I can keep the data in an encrypted form and still do my operations without decrypting it. Okay. So that is a great help for me, so that we can still have control over the data. Yeah, because nobody else can decrypt because they don't have the keys for decryption. So how does it work? So we encrypt the query and send to Google, let us say, right? And Google does not know the key and cannot see the query also, right? And Google applies the query in the encrypted form on the encrypted data, and the result comes, and that result is sent to you, and you will be able to decrypt, and only you will be able to decrypt the data. So that's the kind of thing we are looking for. So what is that? How does it work again? So I keep the data on the cloud in the encrypted form. I send the query, even the query is encrypted. Okay, so nobody should know what query I'm sending. And Google does this operation directly on the encrypted data, and the results are sent to you in the encrypted form, and which only you can decrypt. So this is this kind of solution we are looking for. Does this exist or not? That's what we are going to discuss. Right. Yeah, this is a picture. The same thing you explained, slightly different way. Okay. So you can see that we are sending query X, and we get the result f of X. Okay. Right. The Google actually does this function f and send the results to us. This is in the plane. So, but it doesn't provide the privacy. So what you do actually, I encrypt X and send it, so that nobody knows what I'm asking for, right? And you can see that we do, f of X, right? And then the encrypted value of f of X is sent back to you. Okay. So that nobody knows that what is happening. Yeah, this is slightly explained in a different way. Yeah, now let us see the possibility of this, how far it is possible. So the problem here is we want to do the operations directly on the encrypted data, obviating the need for decrypting. Or you want to protect the data which is in operation. So we want to protect the data even during operation. So that's what we are looking for. So can we do that? Yeah, there is a hope for that. Because there are few examples. Let us look. I think all of you know that if you are using RSA, this is what actually happens. If you are, let us say, encrypting message M1, okay. Basically you take the exponential of M1, okay. Similarly, E of M2 is basically M2 to the power E, right? And in fact, RSA supports is multiplication of. Look at this, okay. If you multiply E of M1 and encryption of M1 and encryption of M2, basically you multiply M1 to power E and M to power E, and then you can see that you can rewrite the same thing in this form, and this is same as E of M1 and M2, encryption of M1 and M2. So that means what you can do is encrypted form of M1, okay, encrypted form of M2 can be directly multiplied, which results in the encrypted form of M1 and M2. This property we called as homomorphism. This particular property we called as multiplicative homomorphism. And what we learned from this is RSA supports multiplicative homomorphism. Okay. Right. So that means if the data is encrypted using RSA, then we can directly multiply them, okay, without decrypting the data. But this only supports this operation, nothing else. Okay, the RSA supports only multiplication. It doesn't support addition. It doesn't support division, or doesn't support any other operation. But only this gives a hope that there are some encryptions which allow operations directly. I hope you are getting the point here, right? So if you see encrypted form of M1, encrypted form of M2, which are basically M1 power E, M2 power E, and these are basically, if you verify mathematically, it looks like you can actually multiply this encrypted form of M1 and M2, and you can directly get the product of this M1 and M2. Okay, as demonstrated here. Yeah, so it gives us hope that there are encryptions which allow you do these operations directly on the encrypted data. Right, but this is only multiplicative homomorphism. But if it has to be fully homomorphic means any operation should be able to do it. Right. Now it should be supporting all the operations. It should be supporting all the operands. The question is, does that kind of encryption exist? Okay. Yeah, if it is additive homomorphism, that is how it should be, right? So what I should be able to add encrypted version of M1 and encrypted version of M2 directly, which should be giving encrypted version of M1, M2. So that is what actually additive homomorphism means. Yeah, likewise, you can define for all the operations. Yeah, what people really wanted was the ability to do arbitrary computing on encrypted data. And this required the ability to compute both sums and products on the same encrypted data set. So we are looking for a solution which permits us to do arbitrary operation. Yeah, let us see whether exists. In fact, In fact, if you look at binary logic, all of you are aware of this XOR operation and AND operation. Yeah, XOR operation is taken for sum, and the AND operation is taken for product. I think all of you know XOR operation, what is AND operation, and so on. And if you look at XOR and AND, both together, they find Turing completeness. That means both of these operations can be used to realize any logic function. So because XOR and AND is Turing complete, any function is combination of XOR and AND gates. I think all of you are aware of this. So this is important for us for understanding our scheme of encryption, which allows you to do operations directly. Yeah, there are simple operations which we know: XOR and AND. Okay, exclusive OR and AND operation. Okay. Yeah, because XOR and AND is Turing complete, if you can compute sums and products on encrypted bits, you can compute any function on encrypted inputs. Okay, so that's a conclusion. So if you can compute sums and products on encrypted bits, okay, in fact you can compute any function on encrypted bits. If you can do XOR and AND, okay, on the encrypted bits directly, you can do any function. Okay, so that's the logic behind that. I hope you are getting the point here, right? So that means if you can prove that there is a scheme which supports XOR and AND, then you can conclude that it works for any arbitrary operation. Yeah. Somewhere in 2009, Craig Gentry, actually, who is a research scholar at Stanford University, he has worked on that, and then he is the one actually. He said that there exists like an encryption scheme which is fully homomorphic. You are getting the point? Fully homomorphic means it should support any arbitrary operation. Okay, but if you go by what I've just now said, only thing is he has to show that this XOR and AND work. So because any operation can be realized as a combination of XOR and AND. Okay, that's the point. Okay. Yeah, so this all further you can explain. If C1 is ciphertext of M1, C2 is ciphertext of M2, and I should be able to do addition of this or multiplication of this. Right. So C3, I should be able to do C1 plus C2, and C4, C1 multiplied with C2. Okay. So one is called additive homomorphic, other one is called multiplicative homomorphic. Okay. Yeah. Yeah, please observe that if you can't do directly, then what is that you do? Even if you have encrypted, let us say M1 into C1, M2 into C2. If you want to do addition, you have to decrypt, get back your M1, decrypt C2, get back M2, and then add them. Once you decrypt, the data is in the plain text and is exposed. Okay, that's exactly, we don't want to do that. instead, what we want is we want to add directly the ciphertext. Okay, C1 and C2 directly added. C1 and C2 are directly multiplied. Okay, so addition here is basically XOR operation, multiplication is basically AND operation. Okay, and see again, whenever I want, I can actually decrypt. You can see when you decrypt C3, you get back your M1 plus M2, and if you decrypt C4, you get your M1 multiplied M2. Yeah, this is a basic point actually you should understand. Right. We'll move on. Next. Okay, I think the same thing is put in a form. Plain text M. Okay. I want to do an operation F on M. Okay. So normally I would have done F directly on plain text, in which case I get F of M. We don't want to do that. Okay. We don't want to do, for obvious reason, because data will be exposed the moment it is in the plain text, and if the data is in the cloud, then you have to decrypt and make it available for operation. Once it is decrypted, it is exposed. Instead, what you want to do, M is encrypted, it is put in the encrypted form. Okay, ENC of M. Now what I do is I do my operation F directly on encrypted version of M, and then it should result in encrypted version of F of M. Yeah. So whenever I want, probably I can get that decrypted into F of M. Yeah, I hope you are getting the point. Here we have M. We want to keep this in encrypted form always, and because homomorphism allows me to do the operation directly, I'll apply F on encrypted form of M and then get that encrypted form of F of M. Okay, and whenever I decrypt this encrypted form of M, I'll get back my. If only this is available, then I can keep the data on the cloud safely and still have the control over my data, because nobody else can decrypt, and there is no need for decryption when you want to operation. That's the whole idea. Okay. Yeah, if fully homomorphic encryption is at your disposal, then you have amazing application. So basically, you can delegate arbitrary processing of data without giving away access to it, without giving away control to it. Okay. So you can do operations directly on the data. So that's the whole idea. That's basically your. This applies very much in the cloud environment. Right. Yeah. Now what we are talking about fully homomorphic encryption. Okay. And people try to do this for years and years without no success. And in 2008 and 9, actually, okay, 8, the fake Gentry has proved that there is a kind of encryption which supports this property, and which we call as fully homomorphic encryption. Okay. HE, fully homomorphic encryption, is okay. It has proved it. Well, briefly look at how it works. Right? What is the magic behind this? Right. Yeah, should I go ahead? You people able to listen to me?
Yes, sir.
Nice. Yeah, this is what we are discussing is basically Craig Gentry's solution. Okay. In fact, what he has done is he wanted to encrypt a bit, a single bit B, for which he has taken a secret key, a large number B, and then um, pick a random large multiple of P, and then say Q dot P. Okay, so these are all number theory. In simple terms, I'm explaining. Now, ciphertext is constructed using this Q, P, and B as well. Because ciphertext of B is basically Q dot P plus 2 into R plus P. Yeah, very simple. What is taking is basically there is a key called P. P is the key. Suppose he has taken product of Q and P, where Q is a random number, which is in the order of n to the power 5 bits, it's a very large number, and multiply this key with P with Q and get the product, and then add B. B is the bit which you want to encrypt, okay, and add some noise as well, okay, that is 2 into R. These things will be clear as you go ahead, okay. Right, and that is a ciphertext. He said that is a ciphertext. Ciphertext is basically product of the key and a random number, large random number, and add 2R plus B, where B is the bit which you want to encrypt, and 2R, okay, is again a small random number. So you have taken R and multiply with 2 and then add this, right? And to decrypt the ciphertext C, what you have to do is you have to do mod operation on C of C mod P. If you do the C mod P, the remainder will be 2R plus B. Okay. 2R plus B. The remainder is 2R plus B. 2R is basically even number because you are multiplying with 2, whatever may be R. Okay. Now, if you look at the bit pattern of 2R plus B, right, the least significant basically gives you B, right? I hope you are getting. If it is 0, it is 0. If it is 1, it is 1. So read of the least significant bit, that will define your plain text, and that defines the decryption of C. I hope you are getting the point. We just encryption is defined as C equal to Q into P plus 2R plus B. Okay, I think P is a key, right? Yeah, this key, P is chosen in the same manner as we choose in public key encryption. So, okay, Q is a random number. R is also a small random number. The purpose will be clear a little later. And B is the plain bit, and that defines the ciphertext. And to decrypt, you just have to do mod operation with P, and then you get that 2R plus B. And because 2 multiplied with R is always even, right? Even always ends with 0, and when you add B, basically just least significant bit, right? And we just read off that bit that will define the plain text. How secure is this? Okay, this is there is no noise, right? That means if R is 0, and if you are given 2 encryptions, you can easily get P. That is no secret. That is no encryption. It doesn't serve the purpose. Okay, you just take the GCD of these 2 encryptions, then you get P. It's so simple actually. And this is exactly the reason why we are adding R. If you add R, then the problem will not be there. Right? How secure is this? But if there is noise, the GCD attack doesn't work. Neither doesn't any attack. So that is as simple as that. So, because we are adding R, GCD attack doesn't work. So it is foolproof to GCD attack. So that's the reason why we are adding R. Or in other words, protects it from GCD attack. Okay. So what is GCD attack? If you are given 2 encryptions, you can get secret key easily by taking GCD of those 2 encryptions. Okay. Yeah, this is also called approximate GCD assumption. Okay. Yeah, that's fine. Now, that's the encryption part and decryption part. So just now I told you how to encrypt and how to decrypt. But how does it support these operations? That is the point which we will discuss. Right. In fact, I told you that in order to support arbitrary operation, it should support 2 operations, XOR and AND. Okay. It supports it. So he has proved that can be done very easily. Right. You can see that as C1, ciphertext defined over B1. B1 is the plain text. B2 is the plain text. They are simple bits. Okay. So as earlier, you will do the same thing, right? To encrypt B1, basically you take a key P and then multiply with Q1 plus 2R1 plus B1. C2 is basically constructed in the same manner, basically Q2 into P plus 2R2 plus B2. If you add C1 and C2 exclusive OR operation, it will result in P into Q1 plus Q2 plus 2 into R1 plus R2, B1 plus B2. Okay. Right. And similarly, if you do the multiplication, that's what it is. It's a simple multiplication, you can see, right? C1 and C2 are multiplied. Yeah, if you see C1 plus C2, the once again the same logic which I have explained. 2 into R1 plus R2 is basically a kind of when you actually do the mod operation, then again you get back your B1 plus B2. Okay, how do you get? The least significant bit actually defines B1 exclusive or B2, that we are calling addition. Okay. Similarly, if you multiply C1 and C2 by the same logic, okay, you see the remainder only will be there. The remainder is basically 2 multiplied R plus B. Okay. In this case, of course, R and R2 are also there. And look at the least significant bit again in the AND operation, B1 and B2. The least significant bit defines B1 and B2. So what I mean to say is, if you are, these are encryptions, of course, and you are directly adding and multiplying. And in order to decrypt, you just have to do mod operation with P. When you do the mod operation, you get back your sum bit and as well as product. Sum bit as well as product bit. So you're getting back your plain text. Okay. This one actually has been. Anyway, this 2R plus B is known as noise. Okay, we call it as noise. Okay. I hope you are getting the point here. When I take the mod with P, you can see that because the first term is product of P, that will go. The remainder part will be there. The remainder part, now if you look at the least significant bit, you get your plain text. Your plain text. Okay. That happens both in the sum and product operation. Exclusive OR operation and AND operation. But there are problems. Okay, it looks very nice, but the problem still exists. Okay. The ciphertext grows with each operation. Okay. What I mean to say is, if you go on adding, multiplying, the ciphertext grows and grows. Okay. And then what happens is the noise also grows. Noise also grows. When the noise grows, then it might offset your reminder. Okay. Reminder, no more is small enough to extract. Okay, that's the problem. So I'll tell you with an example. We'll see that. So if you see again, C is basically QP plus 2R plus B, which is basically encryption. That is the encryption of B. Encryption of B is basically QP plus 2R plus B, which we are calling C. Okay. As we do these operations repeatedly on the same data, the noise grows. Noise, which you are considering as a reminder, okay, is always much less than P. Much less than P will become considerable. Okay, will become considerable. If you go back, actually that part is much less than P. And always it results in a reminder, and that reminder is you can look at the least significant bit and then extract your plain bit. Okay. But what happens is when this noise grows, it becomes comparable to P. When actually it exceeds P by 2, it doesn't work. Right, reminder mechanism doesn't work. Okay, that is what actually this diagram shows. You can look at this. This is just fabricated example. You can see that where P is considered as 17 and noise has become 14. When the noise has become 14, which is comparable to P, or in general it is, if it is greater than P by 2, then this problem is there. If P is 17, then noise is 14, decryption will recover a noise which is 3. And if you see 3, which is wrong, that is considered to be wrong. You just look at this example. So, right. So what happens is when the noise becomes considerable, then this doesn't work. It fades. Okay, if the noise now is greater than p by 2, then decryption will output an incorrect bit. Okay, so that means there is a limitation to this what we are doing. So that's the whole problem. The problem here is as we go on doing these operations repeatedly on the same bit, the noise grows. When the noise becomes considerable compared to the key, secret key P, in particular, if the noise greater than P by 2, it doesn't work, as the example is shown here, right? If noise is 14, and if it is added, okay, for example, it is, let us say it becomes minus 14, so it becomes, the value becomes 20. When you take the mod operation on that 17, it will result in a noise 3, which is not correct. It is not correct. If you see noise is 14, which is actually even, and it is resulting in odd, the result will be wrong. So that's the idea. Right. Ciphertext grows with each operation, useless for many applications because as it grows, the noise grows, and then it looks like it doesn't serve the purpose. And we can't go on doing these operations. So that means you can only perform limited homomorphic operations. So this is a problem actually. Okay. But then of course, Craig Gentry has worked further, and then he has devised a mechanism for limiting the noise itself. We'll not go in great detail about this, but I'll give you the idea of what we've done. Right. What we have found is actually as noise grows, then it this scheme doesn't work actually, as explained just now. No more, the least significant bit is the bit that we wanted. Okay. Different from what actually we wanted. Okay. So what he has done actually, he believed that if you can go a large part of the way, then you can go all the way. So he believed in that actually, and then tried, and then of course came with a solution. But how can it be done actually? So he has used what is known as bootstrapping mechanism. Okay. I just put in a few sentences. Okay. Yeah, those who are interested actually can go through that. Bootstrapping is a technique to remove noise by passing the ciphertext and encrypted private key into a circuit that represents the decryption algorithm of FX scheme. Okay. So what he has done is basically he has devised a mechanism to remove the noise. As the noise increased, he has actually applied homomorphism on that itself, and then has seen that the noise is kept at a low level. Okay. Bootstrapping procedure effectively refreshes the ciphertext by applying to its decryption procedure homomorphically, and thereby obtaining a new ciphertext that encrypts the same value as before but has lower noise. What he has done is basically he has encrypted further, and then has seen that the noise is kept at low, and that so that it not exceed that p by 2. Okay. Yeah, those who are interested, you can go through. It's mathematically intensive. I have not put that. Basically, he has used a bootstrapping method, which contained the noise within the limits, so that you can apply arbitrary operations on this data, and you get back your data. Decrypt. Yeah. this is a these are the how far it works. There are limitations. The computation time is very, very high. This scheme was taking more than a second for encryption of a single bit on high-end machine. So 1 second is too much of time. Recryption primitive taking nearly 30 seconds for the lowest security setting. So all this it takes a lot of time to encrypt a single bit. Okay, and it is also occupying a lot of space. It is occupying 780,000 bits for encrypting a single bit. Okay, so obviously we cannot use this as it is, but it has given a hope that we can have this homomorphic encryption, right? And Craig Gentry himself is working on that, and maybe in the future we may have a practical solution for this. But then there are many people who are working on this particular area. Yeah. So what is that we have learned? Basically, we learned that there is a need for having control over the data that is put on the cloud. And we examined that data undergoes different states during its life cycle. And then we have found that there is a need to protect the data when it is in operation. Okay. And what we essentially wanted is basically, we wanted to keep the data in the encrypted form and still do operations directly. Okay, so that we still retain the control over our data. Okay, how does it work? I encrypt the data and keep my data on the cloud, then do the operations without decrypting the data. Okay, and for this we need a mechanism. And Craig Gentry in 2009 has actually proved that there is encryption that exists. Okay, and we have examined the encryption. So what we have done, C equal to QP plus 2R plus B, that is the encryption, and reverse, we do the mod operation and get back. But it has got its limitations. Okay, we have seen the limitations, and of course, Craig Gentry himself has proved that it can be overcome by what is known as bootstrapping. But in spite of all that, actually takes huge amount of time to encrypt and huge amount of data it takes for storing the bits. Okay, so yeah, so there are lots of encryption schemes now coming up. People who are interested, actually, you can take the cue from this Craig Gentry's work and then do some improvements. Yeah, people are trying to improve further, and then a lot of improvement has been made in terms of efficiency and so on. Okay, right. There's a lot of hope for that. Okay. Yeah. Now, what we do is we move on to the next topic, that is partial homomorphic encryption. So, but then in parallel to what Craig Gentry has done, people also have looked at other homomorphic encryptions or partial homomorphic encryptions, which basically support one or two operations. And then how can we put them in a workable way? So, yeah, what we are going to do is basically do have some partial homomorphic encryptions. Okay, if they are there, then can we make use of them for our advantage? Okay, in fact, there are plenty of such algorithms that exist, and a few more are coming up. For example, Taylor algorithm, okay, which is additive homomorphic. It supports what is known as addition, right? That means you can do addition directly on the encrypted data items. Okay, that's the kind of thing. Yeah, in fact, there are quite a few. RSA actually supports multiplication. Elgamal supports you know, multiplicative algorithm. And Benalo algorithm actually is active homomorphic. So I mean to say there are algorithms which are support one or two operations. Okay, RSA is a public key which supports multiplicative, and Elgamal is public key again, it supports multiplicative. Benalo is again supports additive homomorphic and so on. Yeah, in fact, there is a list of these things here. Failure supports active. There is Hashe Stern supports additive. There is Motto supports additive, and there's another one additive, and so on. Because these partial homomorphic encryptions are coming up. So can we make use of them? Yeah. This is a CryptDB is a solution that is worked out at MIT. There is a researcher called Raluca Popa. She has demonstrated that these partial homomorphic encryptions can be cleverly put together and then make use of this property. Yeah, she has used very effectively for database protecting the data in the relation database form. Right. That group has provided in the form of proxy. Okay. Here this diagram shows actually database, the database server, and we have application at your end, and these applications, they send queries, and the query has to be sent to the database server, and a result should be given to the user. Okay, but in between there is a proxy. I'll briefly tell about the proxy a little later. Then see, query is sent, and the proxy actually encrypts the query and then sends to the database server, and database server gives data in the encrypted form, and it is decrypted, and the result is sent to the user. So proxy can be placed in your place as well. Okay. Yeah, what they have done is basically they have used onions of encryptions. Okay. What actually it means is that they have looked at the data and then see what are the operations that we can do on the data, what operations we have to do on the data. Okay, if it is a text, most probably you should be doing only search operation. You'll not be doing addition, multiplication, and so on. Right, and there are values which will be only adding them. Okay, there is some data which you are adding as well as multiplying and so on. So based on what actually you are doing, you basically prepare onions, onion layers. I mean to say that what they do is basically they do multiple encryptions, right? For example, if you look at onion equality, right? So there is the plain text value. On that there is a join homomorphic operation, encryption, and there is another layer that is called deterministic encryption, and over and above we have random encryption. That is the ultimate thing that we can do. Similarly, we have other onion that is called onion order, on which we are doing OPE, right? Order preserving encryption, which support join operation, and order preserving encryption, and then R&D encryption. So we can actually prepare these onions of encryptions on the columns of the data, right? And then actually you can decrypt only to the extent that is required, and see that always some layer is present, so that you don't have to decrypt completely. Okay, so this is the idea. The idea is you only decrypt, you never decrypt all the layers, right? So that means you always see that at least one layer is always there, right? So what I mean to say is, supposing that you want to do in the first onion equality, then you can see that if I want to do some equal operation, then I can remove R&D. If I want to do join, I can remove DET. That's all. But I don't have to remove join also. Okay, so that's the kind of thing. So how does it work? Proxy server prior analyzes the computation on a column and decide the suitable onion layer. Okay, so basically, so in fact, you have to guide as a database designer. You must be guiding the proxy that what are the operations that you'll be doing. Based on that, it will choose the onion layers, and it does the onion layering. Okay, and proxy does this. Onion decryption is done by the DBMS server at the time of SQL query processing over encrypted data. So whenever you send a query, it will see, it knows this is called SQL aware encryption. That is why. So it knows what layers are there. It will remove that particular encryption layer and then does the operation, and the result is passed to the proxy. Proxy will decrypt and then send to the user. So if you see that if it's carefully done, okay, then there is never a need to expose the data. But only thing is you have to do it carefully. Okay, so yeah, this is what is known as Cryptid Project. This Cryptid Project is done at MIT, okay. And in fact, it is available for downloading as well. You can download and then see how it is working. Yeah, this is an example which is given. Again, you can see here the database, which has employee database, rank, name, and salary is given. You can see here, if you see here, salary, it's 60, 100, 800, 100. If you look at the data, salary is in encrypted form. You see the second and fourth, they have the same values. You can see that query is basically select start from employee where salary is 100. In fact, it returns 2 of these values. Right. Similarly, you can see that I want to do an operation which is greater than or equal to 100. You see the 100 is also encrypted there. So the query also is encrypted. So that people will not make out what it is. Okay. You can see that, if it is greater than 100, then all these three rows are. Yeah, if you look at this, so what you have to do is, if you look at this, because we are doing such kind of operations, range operations, we have to do what is known as OPE encryption, order preserving encryption. I hope we are getting the point. Order preserving encryption. It's not very strong encryption, but then some amount of encryption is still there. That's the whole idea. OPE is basically order preserving encryption. What does that means actually? When you encrypt, the order is still maintained. Order is still maintained. Okay, that's the whole idea. Right. So that you can answer all these queries. These are called range queries. Greater than, less than, right? Between, all these are ranges. If you have to answer such questions, now I cannot do AES on that, right? Random AES on that, but rather I can do deterministic AES on that, so that order is maintained. Okay, so with the help of proxy, actually you can encrypt and decrypt whenever you want, get the results back, and you are actually not keeping the data in the plain text on the cloud. That's the whole idea. The idea is CryptDB. We use SQL aware encryption strategy. Okay. SQL aware, in fact, the database knows which onion is used for which call. Okay. So obviously, whenever it wants, it has to actually decrypt and to that extent required, and then answer the query. And we should also see that there is never a necessity to remove all the layers. Okay. And you are basically adjustable query based encryption. That means you have to, sometimes you have to remove the layer and then put back the layers and so on, depending on the queries that you make. And also there is an extensive mechanism where password key chaining is done. Okay, so password and key are, there's a lot of details which I'm not covering actually. User credentials are used to create the master key from all other keys which are derived. Okay, so your password and keys are tied together so that you get those keys. Remember, for every encryption we require a key, and we have to manage the keys. Keys are managed within the proxy, and of course the password plays a very important role there. Okay, this is what I will explain. These are all various SQL aware encryptions. You can see OP is at the list. Search, join, DAT. There is a encryption called homomorphic encryption itself, which supports addition. And obviously, RND is the one which actually provides the highest security. Okay. Of course, there are varying degree of security they provide. OP is the least one in the order. Just imagine that you want to keep your data on the web in the encrypted form and still search. Okay, there's a lot of research that is going on this area. How do you apply search on the encrypted data so that you don't worry people are looking at your data? Okay, so that's a great application. In fact, there are many works that have been done. Even our own students are doing a lot of work on that. How do you compute search operation, okay, on the data? This is essentially the operation that we do on the web. Okay. Yeah. Can we keep the data in an encrypted form on the web? That's a question. In fact, that can be done. Okay. So people are doing that work as well. Okay. I've explained this. You can see that if this is a query which I want to do on the data item, okay, you can see that how it is done. So first thing is that select query results into set of queries. First thing is, first you have to remove that layer, okay, random layer. You see that that layer has to be removed. R&D layer has to be removed. If you have to remove, then I have to apply this update query. That will remove that. And then now because DET supports equal operation, so then I can apply directly on that. And then, so, right. So I hope you are getting the point. So each query goes through all these steps. And the proxy database, they work together to solve this problem. Right. Yeah, as I told you, this is in fact achieved by having proxy in between, which takes your queries, encrypts queries, and then gets the results, and then decrypts the results and gives to you. And it is the one actually which does put these onion layers on the data, and then each query actually interprets and then generates additional queries, so that each time you have to decrypt and encrypt, it will have to update the database. Okay. And it doesn't require any much change in DBMS, and it works most of the DBMSs. Okay, this is a practical one, and those who are interested, they can read further. Yeah, in fact, they claim that they have to do only a change of 86 lines of code in MySQL. No change to MySQL. Yeah, it's a very CryptDB is the first practical DBMS for running most standard queries on encrypted data, runs queries completely at server, provides global privacy guarantees, and the modest overhead. The overhead is to the extent of some 18%. Does not change DBMS or client applications, and protects data of users logged out during attack, even when all servers are compromised. Okay. So CryptDB is one of them. There are other practical solutions that are coming up. In fact, Microsoft is working, and Google is also working, and Microsoft has got some project actually. Soon they may come up with some solution to offer this kind of CryptDB solutions. All right. What I will do is there is also another system that is called Mylar. It's a MIT project. Those who are interested, they can go through. And this is basically to support search operation on the web data. It's very interesting. People can look. Basically, it allows you to do search operation directly on the encrypted data. Yeah. So in summary, security requirements only grow as the technology evolves. In fact, people started looking at this homomorphic encryption seriously only after the cloud has come. Before, in fact, people knew this, but then they were always doubting whether it is possible or not. But now that it has been made possible, hackers always pose a challenge to the security designers. IT designers have to be aware of threats, vulnerabilities, solutions, and there is always scope for the new security mechanisms. And of course, students should be aware of security requirements and possible solutions. And what Craig Gentry has done is a breakthrough research, and it has opened up a lot of scope for doing research in this particular area. And already we started seeing result of this work. Okay, and those who are interested, they can pursue further. Okay, so what we have done is basically I've explained the Craig Gentry work of FHE, fully homomorphic encryption, and we looked at the need for this in the cloud, where actually we want to put the data in encrypted form and then still do the operations. And we also have looked at the limitations of this Craig Gentry solution, but then there are some practical solutions. And one work, CryptDB, which is done at MIT. This is mainly work of Raluca, a researcher there, and she has put all these partial homomorphic solutions together and then made a practical solution. Yeah, these things are happening, and in future you might see more and more, and that will go a long way in protecting the data. Thank you very much. Hello.
Thank you, sir. Any questions from the participants? You can post your questions in the chat box. Okay. Meantime, I would like to take this opportunity to thank our honorable speaker today. Thank you so much, sir, for taking out time from your busy schedule and enlightening us with so much of knowledge about the data life cycles and protection, about the most important point I would like to mention that I found it out very interesting is that how are you going to provide security to the data in operation? How is it about the data in operation also needs protection, about the Craig Gentry solutions, about homomorphic encryption scheme, fully homomorphic encryption scheme and the limitations of it, and about the CryptDB, wherein we got a understanding of how we are going to have processing of an SQL query also on encrypted data rather than only on the plain text. Thank you so much, sir, for enlightening us today. And I would also thank you for giving us research ideas where we could, the people who are interested in cybersecurity and data security can take up inspiration from the Craig Gentry problem and continue their research work. Thank you so much, sir.
Thank you. Thank you.
Have a great day, sir. Thank you so much. So participants, any questions? If not, we can take a break for 5 minutes and then till the other speaker gets ready.
Hello.
So we'll take a break. We are sharing the feedback link in the chat. I request the participants to give the feedback for the first session of 5th day. Thank you. Good evening. Sir. Good evening, sir. Shall we start, sir?
Yeah. Can you hear me?
Yes, sir. I'm able to hear you. I'll just give the introduction and you can start, sir.
Let me first share my screen.
Okay, sir.
Can you see my presentation? Hello?
Yes, sir. I can see your slides.
Yeah, go ahead.
Good evening, all. I'm delighted to have the gracious presence of our today's resource person for the second session of day 5. It is indeed a special privilege and a pleasure to welcome Dr. Kurramalaya, sir. I welcome you on the behalf of the organizing team of KMIT. The internet has become more influential in daily life than anyone could ever imagined. What was once a means of allowing US military computers to stay connected has now transformed into an integral method of global communication. With so much important data being transferred across public networks every day, it's no surprise that a small section of the technologically gifted chooses to exploit the more vulnerable among us. As cybersecurity is need of the hour, we today will look into the various research ideas in the field of cybersecurity. So today we are going to enhance our knowledge and we are going to know about what are the different research areas in the field of cybersecurity. I would like to now introduce you to the speaker of today, Dr. Kurramalaya, has been working in Defense Research and Development Organization, DRDO, last 20 years as a scientist. Presently, sir is working in Defense Research and Development Laboratory, DRDL at Hyderabad. Sir has been instrumental in various DRDO projects. Prior to joining DRDL, he was working in Indian naval ship INS Shivaji, Indian Navy. Sir has served and is serving as a reviewer for international journals and conferences. Sir has published many papers in the international journals and conferences in the field of security, of data security. Dr. Kurramalaya holds BTech, MTech, and PhD degrees in computer science and engineering. Sir is a member of ACM, CSI, Defense Science Journal, Internet Society, and International Association of Engineers. Sir, I welcome you, and I will not take more time. With due respect, I hand over the session to you. Over to you, sir. The board is all yours.
Thank you very much, madam, for your
My pleasure.
kind introduction.
My pleasure.
And yeah, for all the participants during the my presentation, whenever you feel and you can feel, you can ask the question anytime, and don't be crowd in asking the question. Be a representative. One representative can actually ask me the question for the entire this session. And whenever you feel any doubt or you feel I'm going after it, you can actually interrupt me. Okay. So basically, I was given this opportunity to talk to you guys on the different research ideas and the cyber security. As you are aware, actually, cyber security has become a buzzword. Can you hear me?
Sir. Yes, sir. You're clear, sir.
Okay. Please respond one, at least whenever I say ask something. Okay.
Sure, sir. Sure, sir.
Yeah. So, so basically today's in this session, I will be, since it is a very vast. So initially I thought of going with the general security aspects. Initially, I will present the basic fundamental problems and in the cyber security domain, and very frequently encountered issues in the cyber security. Then I will going for the various advanced techniques, technologies which are available in the to prevent the cyber attacks and protect from the malwares. Then finally, I will conclude with the various research ideas and areas and domains where actually the students or the faculty or research scholars can actually focus and can pursue the research in those cybersecurity areas. So first, just I will introduce some keywords such as the cybersecurity. Now, cybersecurity, every day now people are talking this cyber attack, that cyber attack, and so briefly, a cybersecurity is various technologies, process and practices and procedures, mechanisms, devices, various things which form the cyber security. And these mechanisms, procedures are meant to prevent unauthorized accesses, damages, attacks. So that is the main, I feel, the definition for the cyber security. So cyber security also sometimes people refer to as information security also. Some people may say it is actually data security. Some people may say it is IT security. So more or less all are actually similar with a minor difference. So there is something called cyber space. So basically it refers to the virtual computer world, and more specifically the electronic media used to form a global computer network to facilitate online communication. Wherever any data is being stored or captured, and we are communicating the data to the one device, other devices. Okay, that could be your desktop, that could be that maybe your actually laptop or servers, your mobile phone or any gadget. Okay, that entire thing forms into the cyberspace. So there is one thing when I was going internet, I have seen there is in the USA one campaign is actually starting. Stop, think, and connect. This is actually this is the campaign, and it is being actually followed the majority of the Americans. So whenever you wanted to browse something on the internet, because internet, the way it looks, it is not the way actually you see. There is a lot of things happens inside. Whenever you click on particular URL, so never think that actually that URL takes you to the location where you are intended to go. It may not happen. So first you stop, okay, think what exactly you wanted. Never actually copy and paste, or Google and something you take it. Okay, you type yourself if you know the actually URL and what exactly you are going to actually connect, where you wanted to go, visit which site, and then only actually connect. And this they have taken the shared responsibility. So they are actually practicing at home, in the workplace, and also in the community. So this has really reduced a lot of frauds, online frauds especially, because so I've seen many ways. See, whenever you type on any URL that on your browser, you see how many actually pages it opens. So finally the last page it comes, so it is something different actually what you are looking. So be vigilant whenever actually you are connecting on the internet. So if you see the domains on the warfare, okay, generally we think it is a four domains or dimensions, that is space, air, and maritime and land. So this the cyber security is actually fifth dimension or fifth domain of the warfare. It actually it falls across all the four, that is space, air, and marine, and also land. So we have to be very careful, okay, in the whichever domain actually you are actually, using this internet. So this internet. So today's towards the end of my presentation, I will be talking about some of the research areas. So core techniques or technologies where actually you can pursue your research, okay, across all these four areas with respect to the cyber security. So these are these well-known concepts. Initially, I told I wanted to introduce the few different types of attacks okay, on your system, that is a denial of the service. It is a basically your service being stopped maliciously. That means a legitimate user will not get the service. And simply sometimes we do hear that actually server is down, server is down. Okay, whenever a lot of connections takes place on particular server or opening the particular application, actually that's either that application or application will be slow or actually it becomes down. Okay, this is a one kind of attack. And there is something called distributed denial of the service, because basically is the rogue user wanted to make the legitimate user not to get the service. So this is another kind of attack, actually packet snipping. Okay, whenever it silently actually listens on the network attacker. Okay, you can connect actually you can connect you can use the Wireshark kind of things. You can simply can see the actual what exactly is going on in the network, what exactly going in the network. To avoid actually such packet snipping, you can some solution you can use, always use the HTTPS connection. This HTTPS connection allows actually a secure communication between source to the destination. That means it always encrypts at the source, and at the destination actually it decrypts. So some kind of password cracking, okay, that is a brute force attack. So the attacker actually sequential tries every possible passwords to break, okay. And also dictionary attacks, and dictionary words are being used in the combination with the words and numbers to crack the actually passwords. And always use the secure and strong password. And also one another important is black and IP address from the logging in after some and failure of the attempts. So these are the few techniques essentially which makes your web application actually secure. Phishing, social engineering. Nowadays, actually, the social engineering, it is this attack is being used everywhere to gather the vital information of the individuals. So try to be vigilant whenever you are using the any social media sites. And another one attack is the man in the middle attack. So you think actually you are opening the, here one example is given, ABC Bank Inc. Okay, the attacker actually sniffs your network and he comes in between and can able to see exactly what are the transactions actually you are using. And he bypasses actually your connection to his system. Okay, you think that actually you are talking to the ABC Bank, but actually it is not. Okay, so there is an attacker in between. Okay, and this attacker also uh, sees that actually the destination is also is coming from the source of the ABC Bank. So this, to avoid the man in the middle attack, you better to use the HTTPS connection again once again, and end-to-end encryption techniques. Privileged escalation is another kind of attack where a privileged user or privileged application supposed to access the actually information. But what happens, a rogue user, okay, always privileged users are known as the roots. Okay, so the rogue user try to acquire the root permissions. Once he acquires the root permissions, he bypasses the all the security mechanisms actually which we have kept in place. So directly he can access whatever the wherever he wants to. In this example, if you see, actually the web server, the web application should access the database instead. So directly the rogue user will access the database. Another kind of attack is the crash site scripting. Okay, so basically this is a server side kind of attack where most of people may be having the habit of writing the blacks. Whenever you write a black, and actually that particular information being hosted on the in the server. Okay, whenever another person access this particular blog, okay, it opens is in his actually browser. Okay, that time along with that particular blog information, actually he embeds some particular malware. That malware actually comes to the the client side, and actually it executes here, and it implants a malware in the client side. So this kind of attacks are also happening. So cross-site scripting attack. SQL injection, I think you people are well aware of what is the SQL injection. Simply, whenever you write a query, okay, if you write simply query as it is, anybody can tap in between and they can modify this query, okay. So something like the condition, if you put A is equal to A, it is always true. So it gets the complete information. So always use the SQL queries in the parameterized way. Put this particular entire information into the a particular variable, you pass that particular variable. So these are the security, some of the security threats which you see. Computer viruses, you are aware of it. Ransomware, I wanted to discuss a little bit about this ransomware. So these ransomwares are the kind of malwares, okay, which comes into the your system and encrypts your complete hard disks or files, important files, and it keeps that particular encryption key with him. So he asks some ransoms, some money, okay, to give that particular decryption key to you. So there are many ransomwares actually are actually rotating in the internet, and be very careful. And to protect from these ransomware, you need to have the actually proper backup, so that actually even somebody your system hacks, also that time you need not to pay any money to that particular individual, okay. You can simply format that particular system, and from the backup you can restore your system back to the original. So always, whenever even I suggest you to ransomware happens, okay, takes place onto your system, don't panic, and simply actually inform to your authorities, okay. The best way to avoid ransomware is always have the antivirus in your system, and rogue security softwares. So these are mostly the third-party softwares which are freely available on the internet. Generally, we think this particular software is freely available, so let me download it, and don't think that actually somebody gives you the software freely. It is always with some cost. Okay, he definitely implants something in your system, and he may take the vital information from your system. So always download the very only licensed and authenticated softwares from the authenticated authorized sites only. And Trojan horses, hardwares, spywares, computer worms, DOS, DDoS attacks, phishing attacks, rootkits. There are actually many attacks. Okay, there are something called zero-day attacks. Okay, nowadays we are hearing this Pegasus malware. There's a lot of actually discussion is going on even in the parliament. Okay, so anybody has any idea on the Pegasus?
Yes, sir. The whole politicians are talking about it.
Exactly. The whole politicians, entire country is actually talking
Yes,
about this
yes, sir.
Pegasus. So it is a kind of actually malware. So basically it comes through for one example, that is the WhatsApp. Okay. So whenever you get it is implanted in your mobile just using a WhatsApp call or a WhatsApp message. Okay, they need not even you need not to click on it. A missed call, also with missed call they are able to enter this malware into your particular system. So whenever you use any these social media websites, be careful. Social media has become the more vulnerable than ever. It is useful, but actually use with care. There are many attacks actually. If you I can keep talking about the security threats, malwares, there are many, but so let's see how to design a secure systems. Okay, the basic idea is to there are it is very clear that internet is vulnerable. Okay, from starting from a person using the desktop or mobile, whatever the gadget you talk, okay, to the highest level in the national security. Okay, there is a threat. There is a big threat whenever there is your system is connected on the internet. So in such scenario, how to actually design the secure systems. Okay, so that you can say that actually my system is some secure. Especially in this particular next 5-10 minutes, I will cover the few web applications. Okay, to make you should make them actually secure. Okay, so later I will go to the data security. Also security through obscurity. So this is basically you should not reveal the technique, the algorithm which you are which you are using in your application to protect. Okay, this is a simple basic the fundamental things. Okay, so something like here is our authentication database goes down for 2 minutes every night at 4 p.m. Don't declare it. Okay, if an attacker knows that actually this time, okay, you are down, authentication is down, so he can actually get into your system. This is just an example I'm saying. Let's say you are using an encryption algorithm, okay, and don't declare that actually you are using so and so, because the moment they know that actually you are using so and so algorithm, okay, they may try to break that particular algorithm. Okay, it may be possible. Okay, so this is one method. So the secure authentication, always use the two-factor authentication. And this particular authentication, generally username and password. Okay, so there is a three ways of generally we use the authentication mechanisms. What you know, what you are, what you have. So what you are means actually something like your retina kind of. What you know means the passwords. What you have means some kind of smart cards. Okay, whenever you use these three, protect these three first, because this is a very basic thing. And most of our I have seen and I've experienced, I have audited the many systems, okay, in the outside in defense also. So people have the tendency to have the only one password across all their accounts. I've seen it, and that password is also very trivial. If somebody knows that particular password one time at particular one site, okay, because in the social media, so much of things are going on, so much of data is being shared. Okay, you think by giving somebody, okay, you think actually it is secure, but actually he may pass on, he may take some inference, but that particular information to guess your particular password. So please always use a very strong password. And privilege, principle of privileges, this is should be the fundamental the principle whenever you actually design any secure systems. Give the authentication or authorization access rights to the your applications, your systems, whatever. Okay, minimal it wanted. Okay, the least, don't ever give even a single one extra permission to that particular application which is not at all required. So whenever you download actually any mobile applications, it asks a lot of permissions. Have you ever observed? So most of the time you install your application, it asks your contact, it asks your SD card, it asks blah blah. Many things actually it asks. Actually it doesn't require. Let's say you wanted to play an online game. Okay, why it wanted to have to access to your SD card? Why it required your contacts? Okay, they are actually not required. So that means, so be careful whenever you're designing any particular secure systems. So that application should not give the permissions more than it is required. Okay, something like turn off unnecessary services on your web browser. Okay, disable SSH. Okay, SSH is for actually remote purposes. Whenever you wanted to access in your system remotely, that time securely, you wanted the SSH. Otherwise, SSH is not required. Okay, or VNC and send mail, many other things. So this should be the one of your goal whenever you design a secure system. Principle of least privilege. So sanitizing the input, this is one of the greatest. It looks very simple whenever you design the web applications. We wanted security, whatever the information actually you are receiving or taking. Okay, that time try to analyze that particular information before actually processing. Let's say, so what is your name? If somebody enters 123 or some text alphanumeric is fine. Okay, so sometimes in this example, if you see what is your Okay, airspeed of something, swallow. So here instead of here actually entering some particular information, he has entered a script here. Can you see here my cursor?
Yes, sir. I can
Okay.
see.
Yeah. So this is the script actually, not information. So this scripts you are taking, and this script actually also you will be processing. That is basically a malware. Okay. So always you have to sanitize your input. Even sometimes to break your applications, let's say your application takes the uh, only 10 characters or 10 digits. Okay, but actually intentionally he enters the a big actually 1 KB 2 KB of data into that particular input. Okay, if you not handle properly, a buffer overflow happens. Okay, that leads to actually either crashing your system or your system may actually compromise. So always sanitize your inputs. So another aspect of secure designing the systems, verify the code. So this is very important. Whatever you have written, you think that actually you have written the very fantastic and fabulous program. Okay, that is for your point of view. Okay, so always allow the third party to review your code. Okay, and maybe intentionally errors or unintentionally, okay, or some problems may actually you can find out some kind of code walkthrough actually you have to go through. Okay, or security audits has to carried out on particular that system. There are actually many tools are available for this auditing or code walkthrough. They could be static or dynamic. Statically they verify against the certain rules, okay, some kind of certainty, certain and all. Okay, this is my point here is to say verify the code, okay, for its security audits carry out on particular your system. Okay, and this penetration testing is a very important thing. Okay, you think you designed actually the better system, but always give the third party to actually penetrate into your system with available actually various attacks. Okay, try to compromise the system, because if you see there is something called the National Vulnerability Database. Okay, this is for those people who wanted to pursue some kind of research, please visit this National Vulnerability Database. This particular database contains the complete spectrum of, okay, all the attacks, the source of the attack, the weakness, and why actually this particular system has been attacked, and its solution and its patch. Okay, if you visit that, starting from your BIOS to next grub loader, next operating system, application, and data. Okay, from bottom to actually top. Okay, whatever all kind of the attacks and solutions are actually available. If you analyze them, definitely you can get some problem. And our approach to design the secure systems is defense in depth. This should be the fundamental whenever actually design any secure systems. The defense in depth is something is called as a multi-layered security. That means you are keeping the security at the different layers, okay, such that at one layer actually it fails, at the another layer it may protect. So starting from, okay, policies, if you see here, okay, every organization should have the some policies, okay, to follow. That means the organization pen drive should not be used. That never allow a pen drive to be used in your organization, or your network internal LAN and internal, that it should be a separate. So this is a just two policies I am saying. So these policies strictly actually you should enforce. So you should have the clear, any organization should have the clear cut policies. And next level is actually the physical security of your entire organization. Okay, so proper physical security you should have it. And next is perimeter security within. Okay, this is entry within. Next, after that, anybody can come into the particular systems. Okay, this is physical security. And next, anybody can come into your systems. You can come through only the network. Okay, and at the entry of your network, have there some kind of firewalls. Okay, IDS and IPS, so that at there itself actually you can catch hold of him. I can prevent the any malware and any attacker trying to enter into the system. So once it's come back to the actually your host, at the host level, at the system level, you will have the operating system. Okay, so have the sufficient security in the operating systems. Okay, here also you can have the host level firewalls. Okay, something like antivirus. Okay, or also Windows Defender. These are the some kind of host level firewalls. They also actually protect your system from the malwares, from the attackers. The next level comes to the application. So whatever the previously we have just discussed, the majority of them are actually web based or application level security. Here you should properly code such that, and also maintain the proper security structure. Okay, so that your application is free from the such attacks. And once after this application is over, come to the actually the data, which is the core of your particular organization and system. So at the data level, you can have the some kind of security mechanisms, encryption techniques, and always keep the data in the systems in the encrypted format, even if the system, and keep the key away from the actually your system. Even if a system compromises, your data is available to the attacker only in encrypted form. So have some this kind of techniques, mechanisms. The mechanism should be in place whenever you design any secure system. So your approach should be defense in depth. Defense in depth. So any questions so far?
No, sir. Thank you.
Oh, okay. So so we have seen some attacks, and we have seen the how to design the secure systems some extent. Now we'll see that actually, okay, how to address the, okay, vulnerabilities in the system. How do we know? Okay, you have designed a secure system, you say that actually the system is secure. Okay, so to say the system is secure, you have to carry out some kind of vulnerability assessment. Okay, you have to assess the system and say that actually my system is secure. There are many open source softwares are available. Okay, just I have listed here some of them. You can just go through on internet. And this is the one of the research area nowadays, vulnerability assessment. Try to find out the vulnerability in the system. Once you have found the vulnerability in the system, and you can have a solution. Okay, and in the form of some patch, or you can have a fresh solution. Okay, so this is a one good research area where you can try to find out. First, initially go ahead with the all the open source available tools, use them. Okay, and find out the vulnerabilities is, as I mentioned just in previous slides, starting from bias to the actually data in the system, and especially the vulnerability with respect to the operating system, vulnerability with respect to the applications. Okay, if you wanted to have the better research, okay, go with the vulnerability with respect to the operating system. And when it comes to the data, it is a plain data. So when the plain data is there, most with respect to how to secure the data. Okay, data does not have any vulnerability as such. So vulnerability will have the either it is the network or it is the system. Okay, so you focus that area and applications. And once you did the vulnerability assessment, you found out at these places, you found the vulnerability in the system. Okay, then carry out the penetration testing. Okay, this penetration testing nothing but you're actually launching a particular attack on the system. Okay, so mostly there are two kinds of hackers generally we know, that is black cat and white cat. Okay, some cats. Okay, I don't remember exactly. Black cats are referred as the hackers. Okay, so the ethical hackers are the actually white caps. So generally, what they do is first they carry out the vulnerable assessment, find the weakness in the system, then they carry out the penetration testing. They launch the attack on your particular system. So for better research purpose for you, okay, these are all are the open source softwares to be used for the penetration testing. And one point actually I wanted to tell you. So nowadays in the cyber security, okay, the research, okay, mainly first identifying the vulnerability in the system. Okay, identifying the vulnerability in the system, and once let's say somebody has actually attacked your system, identifying the root cause of that particular from where actually this attack has taken place. So these two are actually very important. So that area actually, if you pursue your research, it will have the great results. I'm telling you, okay? Because identifying the problem, identifying the root cause of who has attacked your system is very important. This particular sometimes we call also forensics analysis. Okay, digital forensics. I'll cover towards the end of my session that. Okay, these are the some of the penetration testing tools and open source tools you can just practice. I'm telling you, if you have a good understanding of these four, it is more than sufficient to get a excellent job in the actually cyber security domain. And also some of the social engineering applications, major problems, though they are very useful. And WhatsApp, Signal, Telegram, Facebook, and Twitter. Please use with very carefully, because there are actually legality is also associated with this actually social engineering applications. Don't post anything just like that. And in India also IT Act is there. Okay, IT Act 2008, and also recently many acts have come. Personal Information Protection Act, Aadhaar Act, and Personal Sensitive Information Protection Act. So these are actually enforced. Don't just like that. Don't post any information which is harming any third party, any individual or government. Be careful. And here is also I've seen a lot of actually research can be possible here. You just have to focus here. What are the security policies this each application, okay, each social engineering applications are actually providing? If you analyze them, I have gone through all these things: WhatsApp, Signal, Telegram, Facebook, and Twitter. To large extent, mostly, okay, they are following one kind of pattern. I observed actually. That pattern is some kind of nowadays. Okay, two things: two-factor authentication. Some people are following, some are not following. Okay, they are making it optional, and also end-to-end encryption. Okay, that means from source to destination completely it is being encrypted. And analyze the various protocols. Okay, for the cyber security point of view, for the security point of view, how they are providing. List out. Okay, list out. Okay, and try to have a protocol, secure protocol, which can give the better security to this particular any applications. A sample thing if you actually prove. Okay, and that will be research. And here is also a lot of video conferencing applications. Lot of problem is there. Okay, right now actually we are using the Zoom, right? I don't know how many people are actually watching this particular this thing. And one case I read in the newspaper. So there was a big conference was going on with the Prime Minister of UK, I suppose. Okay, somebody has entered into that particular meeting. Okay, so do not share any vital and confidential information on this internet first in place, but be sure, okay, you are using some kind of security mechanisms, then only try to use. And also this VPN is a more dangerous. Even Indian government actually stopped. So we were using the VPN, virtual private network, for to access the public network from home. Okay, but that also having a lot of problems, because see, some technologies are good, that is good for good purpose, but actually bad people are using for the bad purpose. So our idea is to design whenever the secure system, you should always have the CIA, that is actually confidentiality, integrity, and availability. These three should be your motto whenever you actually design any secure systems. Ayesha, hello, hello, hello.
Sir?
Can you hear me?
Yes, sir. Yes, sir.
So how much time I have actually, because this is the cyber security
Yes,
is a
sir.
lot of thing. Uh,
Sir, it is
hello.
actually scheduled till 5 o'clock
Okay.
because you have joined, because the first speaker was due to technical issues. He started late, so you got less time. But
Okay.
you can continue, sir, as much like the topics are covered.
Okay. Right. So that actually I will go to the last whenever some time is there. I will again come back to the general aspects.
Okay,
Okay.
sir.
So basically, mostly you are aware of this homomorphic encryption.
Yes,
Nowadays,
sir.
I think,
We have just Ramachandran sir has
yes,
briefed us
yes,
about homomorphic encryption scheme, sir.
yes. Okay. So I will not cover that actually. I know that HL sir told we will cover that. So did you sir talk about this format preserving encryption?
Sir, sir told about the order preserving encryption.
OP.
Yes, sir.
Okay.
OP.
Okay, that is. So there is something called format preserving encryption. That means this is a, after encrypting also it preserves the order. So you can just see this is particularly your credit card number. So why this order format preserving encryption is important means, okay. So you have designed a secure systems, okay, or some system, some application actually you have designed, and that is it in the place, and that is a legacy application. You did it actually 20 years back, some 30 years back. That time actually security was not a major criteria. Okay. So now suddenly you felt that actually you wanted a security. So for that, there are two things. Either you have to redesign your application, okay, or you should provide the security such that, okay, and the existing structure should not be, okay, changed. Okay, something like you have created a database, okay, a database field name is something like a number. Okay, here we'll take this example only. The credit card number. So this credit card number is always 16 digit. Okay, so you are using say encryption, some kind of AES, let's say. So it gives the more than actually the 16 digits. Can you able to store in that particular field? You cannot able to store. So for that you have to change the design, database design, which is not possible now because who has written we don't know. Okay, for such cases, to provide the security for the legacy applications particularly, okay, something has been proposed that is called the format preserving encryption. So this format preserving encryption is a technique, is an encryption mechanism where it preserves or holds or fits, okay, character by character. Okay, it after encryption also the length is same and the format is same. That means if you encrypt 16 digit credit card number, again you will get the only 16 digits only after encryption. If you encrypt the 20 characters after you after encryption, you will get the only 20 characters only. So after encryption it preserves its order and format. So these are the very important things: order and format and also length. So these three things it preserves. Okay, this is also one good research area. People can actually focus on it. There are some already algorithms are available. How to improve them? Okay, in terms of performance or in terms of security. So that actually one can see. This SAR must have covered it, order preserving encryption. There's something called searchable encryption also, SAR must have covered. So nowadays, this just brief introduction I will give about this machine learning. So machine learning really got the very good opportunities right now. And also next era is of the actual machine learning era. Okay, next 20-30 years, okay, it is going to rule, that is machine learning or AI, artificial intelligence, and the machine learning. Particularly, it is going to be a rule, okay, in terms in the field of the even cyber security also. Because nowadays people are looking for the automated things. Okay, automated things. That means the system should able to learn, identify self, and also actually go for the mitigate the vulnerabilities. Identify the vulnerability in the system on its own, or identify the any malware when it comes, and try to prevent the malware not to enter. Okay, and there are many ways this machine learning is going to very useful in the area of the actually the cyber security, and also in many other areas. Since we are talking the cyber security, just we are particular, I'm just mentioning about the cyber security. And there is something called the actually cyber physical security. Okay, so machine learning, I think most of the you people may be knowing, maybe having a subject for you. I'm not covering much. These are the some of the machine learning, what it is machine learning and all types. These are the three types of actual machine learning techniques: supervised and unsupervised and reinforcement. Supervised means actually they are labeled, okay, and unsupervised means the objects are not labeled. Reinforcement means having the feedback, actually the system learns. So basically you are going to, this is supervised mode. Okay, what this is circle, you have actually labeled, and you have taken a particular, this is data you have taken, a particular algorithm you have taken, and you fed this data to the algorithm. You have actually created the model, you have trained the model, and try to give the new data to the trained model, then it should able to identify. This is actually supervised learning. Unsupervised learning means no labeled data. Okay, you train such that it should able to classify or actually predict. Reinforcement means simply with the feedback. Okay, the boy when he touches fire, he feels that okay, fire actually burns. So something that feedback, again never he touches the fire. These are the some of the machine learning algorithms. Okay, and you can practice. And this machine learning algorithms nowadays is mostly even in our cyber security is being used in the log analysis. There is a firewall in your I think every organization has a firewall. Okay, but firewall is there, it only tries to already existing database, vulnerability database, or signatures actually it holds, or some kind of pattern it keeps and checks. Something matches, then only it will try to stop. Okay, if something it is, whether it is whatever is stopping or whatever it is allowing, is it actually doing right? Okay, and also the best thing is these logs and all, they the best thing is the firewall is it logs all its actions. So try to analyze that particular log, okay, using the machine learning techniques. It gives a lot of information. This is one of the very good actually research thing recently I did, and going to publish a paper on this. We actually found the very interesting results. Okay, so using this random forest algorithm and also support vector using SVM support vector method. So these two algorithms actually are used to analyze the log and see that actually whatever the firewall is reporting, okay, how extent it is true. Okay, and this particular area you can actually go for the state aware research. The much there are not good papers and not available on this particular area. Use the machine learning techniques. Okay, analyze the your actually log firewall logs, and also you can use these machine learning techniques to analyze the digital forensics also. That I will come later. Everywhere this machine learning actually applications are available. And there are actually open source tools are already available. You need not to buy anything. Okay, these are the some of the open source tools Okay, install them and practice them. The blockchain. Hello. Hello.
Sir?
Yes, sir.
Any questions?
So far, no questions, sir, in the chat.
Okay. Please, if you got any question, please ask me. I'll brief
Yes.
about the little blockchain. And
Sure,
this is
sir.
a very contemporary techniques, and the way it provides the security, it got a lot of applications. Okay, majorly there is no trust, centralized trust. Okay, so wherever there is a digital data, wherever there is a information, vital information of the particular organization, so there is no trust, centralized trust in such areas, in such applications. You can use the actually blockchain technology to protect the your digital assets. Digital assets means everything. Okay, in the form of available that in the form of available in your organization in digital form. Okay, there actually you can use the blockchain. And blockchain I'm not going to discuss much because you may aware of, I'm assuming that actually you may aware of about this blockchain. It is a kind of a distributed ledger technology where there are peer users are there, all are peer users. That means everybody has the equal rights on that particular network. They are actually basically peers, and everybody will have the copy of the information and data, okay, having across all the people on that particular network. If there are actually 10 10 in that particular network, okay, 10 people will have the identical copy at any given time. Okay, anybody can actually verify. There are something called the validators, okay, who can validate the your actually the block or transaction before uh, before attaching to the actually the blockchain. So these are something permission or permissionless and permissioned blockchain. These are the two types of blockchains are available. And here one interesting research problem I will tell you. Okay, this and all works and all, you know, I'm not going to in depth of the how it works and all. Okay, see one interesting research problem here is, okay, yeah, one interesting research problem here is in the blockchain itself. You can use this some kind of homomorphic encryption here or searchable encryption mechanism. That means, so in this particular, if you see here, the data available with this particular blockchain is in the actually plain form. It hash is there, or timestamp and hash is there. Okay, this hash ensures this data is always intact. Fine, but I wanted to check this particular things. Okay, whenever they are in encryption form, not in the directly the plain data. Okay, how to test it? How to search it? Okay, just think this is a very good research problem. Okay, and in the blockchain itself, in the block itself, we got these are the parameters. Okay, along with the data. Okay, that data you wanted to actually verify, but that particular data I cannot give freely to the verifier. Okay, in the plain form, you encrypt that particular data and give for the verifier for verification. Okay, how to do it? How to incorporate this particular technique into the blockchain? And I think this is a good research problem. This is Kali Linux is one kind of penetration testing tool. Not doing not much. Cryptid and also almost told. There is something called I was mentioning about this National Vulnerability Database. Okay, so all the vulnerabilities are available in the form of CVs, Common Vulnerability Enumeration. Okay, with numbers and all. Please go to this particular site. Okay, you can see that actually a complete information. What is the vulnerability? What type of the vulnerability it is? Whether it is operating system, application, network, what it entire information it gives, why actually the vulnerability was there, how it is being patched. Okay, so once you know how exactly that vulnerability is being identified and patched, you can see, you can further actually analyze for the new problem. Okay, new problem. So then try to, I would say in computer science research, so sometimes you have to create a problem. Okay, say that actually this problem may happen. Okay, this is a very good research. Always research, your research should be futuristic. Okay, first analyze that this existing thing, definitely you will get the good idea in the for the future. And something called IT Act, I will mention. Yeah, let me first talk about this. Some few things actually I listed out here. Okay, for the potential research areas in the cyber security. Okay, for the student also actually can take up really, if they are really interested, these are the some of the listed research areas. And if you prove at least one aspect, okay, in the listed here about 10-15, okay, you will have the first, you will get the very good job, because it is being told there is a lot of scarcity in the actual cyber security experts. Okay, so there are 3 to 4 jobs are available. There is for the only one person. This is the actual statistics in the cyber security domain. So please practice the cyber security mechanisms. There are the online also. If you do not understand, there is a lot of online material is also available. Online trainings are also actually people are giving. Okay, start with one particular area. Okay, let's say application security. Now focus on the application security. Okay, what is application? What are the attacks on the applications are possible, and how to secure them? Okay, this is one thing, one area to actually research. Another thing is that something has attack actually taken place. Okay, now how to find out the root cause of that particular attack, from where it actually originated. If you see in your mail, if something actually received, okay, you can see a lot of information is available in the mail itself. If you open the headers, how many of you read the headers? Header gives a lot of information. From that particular point, you can actually find out lot many things. Okay, you got your mail, from where you have received. Okay, so on, so IP you have received. Okay, this IP is actually belonging to which place, which ISP. That ISP information you will get. So from that ISP, where in which country this ISP is actually located. Okay, country also will get it. So that ISP from which location actually it has connected. Okay, with this particular connection, who is the connection owner? Okay, the owner in the sense the system. Okay, the system. So just analyze this particular entire chain. Okay, you can find out, okay, from this particular malware originated from so and so systems. This can, you can actually pinpoint. In this area actually lot of openings are there. So something we will call actually digital forensics. Okay, so this is web forensics we call. Digital forensics is something like, say, okay, devices, who has actually connected which devices to your system or in your complete entire organization. Okay, because majority of, now what we are doing, we are always focusing our research how external entities coming inside. That external entity is coming inside via network. So network security. We just think in that. Don't think that way. Okay, from external to inside, outsider, how it is coming. One aspect. Generally, everybody thinks. Think that actually insider, how it actually, okay, passing your information to the outside. Okay, this is a new trend now. Please think from this side. How insider is leaking the information. How a particular malware has come into your system. Okay, is it inside or outside? Always we try to analyze the log, firewall, this, blah, 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 we'll do it. Okay, we'll find nothing. Okay, but the originator is actually the insider. So your research focus should be, okay, inside. Okay, who has, which devices actually who has connected on the which system. You analyze that. Okay, And what are the applications? Okay, this particular system is it is running, whether they are legitimate applications or malwares. Okay, inside us. Okay, this is one of the good research area. Okay, please focus. You think actually differently like this, so we'll get the very good problems. So some of here listed out, I will just go through. The one research area is a secure quantum communication. Now this era, now after few years, now we are we are hearing about the quantum computers. Okay, that's a big thing that may take some time, but quantum communication is actually happening. Okay, that is quantum key distribution, QKD we call quantum key distribution. So key is being actually communicated from the source to destination. Okay, you by generating the polarized protons using the lasers and converting them into the data is converting into the photons. Then these photons actually being communicated from source to the destination. First, they will convert this information, particular data into the protons. Then actually they will share the information to source to destination. So why this is secure? This quantum communication, why it is secure means, okay. So even you need not to encrypt anything here. Encrypt and then at the receive end decrypt. Okay, for that actually key is required and all. But actually when you communicate the information using this polarized photons, okay, if anybody is trying to access your system or try to catch or try to intercept into the actual network, these protons actually changes its state, it corrupts. Okay, the receiver, okay, will get the what's completely corrupted information. You will not able to do anything. Immediately you will come to know something has happened, something has actually gone wrong. Now in traditional secure communication, okay, even you encrypt, somebody has actually decrypted in between and he has completely captured the information and sent to the destination. Even destination don't know anything. He can passively can see, okay, by stippling the packets in between, the man in the middle kind of attack. But what happens in the quantum computing, the moment somebody actually enters into the network, try to see your particular data, actually it changes its state. It corrupts. You cannot exactly see what exactly it is. So this area is one of the very potential area for the research, the quantum communication and secure communication for the space. Now, now one of the dimensions I was actually mentioning about the space, because see now you got the satellites, now you got the mission control systems at the land at the base, okay, and always they are being communicated with each other. So now existing algorithms, it is very clear that actually they are not secure. Now, when see that these systems were designed keeping the performance and efficiency in mind, security was never a problem. Okay, so analyze what are the existing secure protocols or secure or protocols which actually this communication, space communication uses from the mission control systems at the base to the actually satellite, and how the mission control system at the base is transmitting the data, and at the satellite how it is receiving, and how satellite is sending the data on the mission control system is actually receiving it, and how it is interpreting, what are the security mechanisms already available. Just this is also one good research area uh, for you to start. And this cyber autonomy and cyber automation, just I was mentioning about this. So this is actually where your machine learning techniques are, and your AI techniques, your expert system techniques are actually heavily used. So as I was mentioning, your system should able to identify the vulnerabilities on its own. You design such a program, such a model, and keep that particular model program in your system, and this particular your trained model should able to identify the vulnerabilities on its own. Okay, and once vulnerability is available, and you have to design a system, okay, and it's what are the action need to be taken, and vulnerability is identified and it immediately has to patch. Okay, immediately it has to apply the solution. The patch means actual solution to the problem. Immediately it has to patch. Nowadays we can see that actually this automation in the automobile industry, the heavily it is where not actually everywhere in the power grids, automobiles, homes, okay, and internet of things, everywhere it is being used. So imagine a car you are actually driving. This is completely fully automatic, okay, and somebody has actually some security flaw attacker has identified, and actually he can take a completely he can take over your entire car. So anybody has read recently this Tesla?
Yes, sir.
So there was a big news is going on. Okay. So what is his name? I don't remember. Tesla owner. Mark? No. Not really. Okay. There's a big news is going on. So some 19-year or so old boy actually found the vulnerability in the this automatic systems, and he was controlling the entire car. Okay, he was actually completely, what is name, Karl Musk or somebody. Okay, anyway, so he was completely actually controlling the
Elon
car.
Musk, sir.
Elon Musk.
Sir,
Yes.
Elon,
Yes, you are right, Elon Musk. So there is a big news. Did you read? I think. Okay. So imagine that situation. That is a good research area. Okay. So see, the new techniques whenever comes, the new opportunities for the researchers. This is your should be your fundamental thinking. Okay. Now the cars we are automating. Okay. So there also this security comes. Security is everywhere. Okay. Please try to formulate your particular problem in this area. It got the potential, very good potential research in this. Somebody can actually finish within 4 or 5 years. I'm telling you, 3 years also you can finish if you are very serious, because there's a lot of very minimal security researches and very contemporary. Very minimum things are actually research is going on. So whenever you take up any research problem, please always take up contemporary, at least minimum contemporary, or otherwise always should be the futuristic. Okay, don't go by fast and never go by very this is network communication, and that is a vast actually. So over people are I've seen the people are, and again the very traditional things they are going something like I have seen. Okay, what is called firewalls, desktop firewalls, network firewalls, okay, and very old things. Please do not go. Okay, this is good actually if you identify a problem, but always for the better research, for better results, always do the research, contemporary research and futuristic research. And this is a one area because it combines your actually machine learning techniques. Your machine learning techniques are heavily used here. Okay. Now imagine recently I was reading an article. Okay, the car. Okay, automatically it brakes whenever it objects it. The car comes to near to an object. See, imagine. Okay, somebody has actually captured your car. There is a flaw, and he can do anything. And Internet of Things and the physical security. So the cyber physical security. So which I was just talking about, these cars, automobiles. Okay, and Internet of Things. Nowadays, now Internet of Things has reached everywhere. All home appliances now we are being operated with the internet. Imagine, and it is being captured a rogue. Okay, an attacker can do anything. He can blow actually your house. I'm telling you. Now you have put for your AC purpose. Okay, you have put IoT device and you wanted to make it your AC on before you reach the home 10 minutes. Okay, and AC got some kind of what is that, some kind of gases. Okay, and recently 3 4 days back, and one more this thing, your geyser. Okay, there was a news. Anybody read regarding this geyser? One 13 or 14 years girl died in Tamil Nadu or somewhere. Anybody read it?
No, sir. Sorry.
Yeah, because that particular geyser actually releases some kind of gas. Okay, due to that particular thing, actually she died. Imagine we are using the IoT device there, and this particular that particular being captured by the rope, and he can blow. See, by sitting somewhere in this some corner of this world, okay, he can kill you because of this IoT. IoT got a lot of good applications, but due to these cyber security problems, it may misuse. People are actually misusing. Okay, and this is also one good potential area to think of. See, first in research, you should create a problem. Okay, first you create the problem, then think of the solution. Okay, and cyber law and ethics, and actually you can just go through what are the various cyber laws. Okay, whenever somebody did the crime with respect to, I mean to say online. Okay, what are the penalties? What are the policies actually are available? With respect to India, there are, as mentioned, IT Act 2008, 2000 is there, which has been subsequently amended in 2008, and also there's something like that Personal Information Protection Act. Okay, there are many actually. There are some things are here. Okay, just see. We do not have much time to say. And if you see, these are the data protection laws of the entire world. See, if you see the America and all, they are heavy. They are clear-cut rules. Okay. If somebody did any crime or mistake, definitely he is going to be caught and he will be punished. Okay. If you see this Russia and all, they are robust, not much. Okay. But when it comes to India, just see, very limited. Okay. If some research problem here it is, just collect this entire complete information. Okay. So what are the data protection laws across the world and analyze them, and you can propose a better, and why it is possible here, why not in India, or why not in China or some other countries, why not in Brazil? Just analyze them and formulate a particular problem. Okay, just hello. Presentation mali call చేస్తాను. So this is a very good research problem actually, one can see here. So here I was cyber laws and ethics, you can see, and cyber criminology and cyber forensics. So nowadays our actually police department and our CBI and various these people, they are using this cyber criminology and cyber forensics to identify the actually crimes. Okay, this is also very good potential area you can actually take up. Okay, and critical infrastructure security, something like the physical, it also comes under the actual physical security also. See, you got the in the country power grid. Okay, and the power grid is there nowadays, all banks. Okay, and physically wherever you are actually protecting with help of the internet of the things, or with the internet and with the network. In such area, there is a very potential research is available, because we've seen in the Iran. Okay, Iran or Iraq, there is this nuclear plant was down for more than a week because of simple one USB some stuck nets. Okay, because of that complete power grid was down. And recently in our here also in Mumbai, okay, there was a red echo. This is the Chinese has implanted, okay, this particular malware, and there was a power cut in the Mumbai. So most of the critical infrastructures, okay, so they are networked and they are being handled with IoT. So there is also a lot of security problems are there. So that is a good potential area for the research. And cloud data security actually sir must have covered. There is no doubt. There's a lot of research is available in this data security. So I was mentioning about this firewall analysis using the machine learning techniques. This is a one straight away problem actually one can take up, okay, and analyze. And this national security policies, and with respect to the security policies, which country is actually providing the which type of security, that also you can actually see. And you just tabulate and you provide, you give the your own actually policy or security mechanism. And mobile application security is also very contemporary. So there is a lot of actually malwares are being installed whenever along with some rogue, along with some applications. That area is also one potential area. And homomorphic encryption, sir must have told it. That is a very good area, very contemporary and also futuristic. Still, not much usable solutions are available in the homomorphic encryption. Please practice. Okay, there's a lot of problems are available. Everywhere you can use the homomorphic encryption techniques. And format preserving encryption this time mentioned, and order preserving encryption is also a good research area. Okay, so with this I will conclude that cyber security, the requirement is everywhere. Okay, so everywhere it is there. Whenever you are choosing the research problem, okay, you first understand the complete existing solutions, existing protocols, the mechanisms, then try to pick up a particular domain. Okay, if you got any problem, please ask me any questions.
Yes, participants, the chat box is open and sir is available for taking up any questions from your side.
No questions?
I don't see any questions coming. In meantime, I would like to thank and
Okay.
brief session.
Okay. Our people are actually here listening. Yeah, somebody run was okay, anyway, go ahead.
Thank you, sir. Your session was very, very informative. You have given us information on the different security threats and how we are going to be, how we should be safe against such different attacks. And the main catchy line of today's session was about to stop, think, and connect. Before you do any data transfer or any transaction, you have to stop, think, and connect. That was a very catchy line for today's session. And we also, you have given us information about the open source softwares available. And you have told us how whenever we design a solution in security, what is the triad that we have to follow, the CIA triad of confidentiality, integrity, and authentication. You have given us so many problem statements related to research areas in format preserving encryption, in homomorphic encryption. And you have also told us how the ML algorithms can be used in analyzing the firewalls, especially in cyber autonomy and automation. And you have given a very good idea of how we can have security in data, in the data of the blockchains, and like how those data in the blockchains are given to the verifier in an encrypted format rather than plain text. And what are the research area opportunities available in digital forensics, in secure quantum communication, and secure communication for space. And most importantly, as IoTs become very important and popular, how are we going to provide security? And most importantly, because the topic was about the research ideas in cybersecurity, you have given us a very important concept or a teaching that the research should be contemporary and futuristic. It should not be traditional. So thank you so much, sir. I thank you from the organizing team of KMIT that you have taken out from your busy schedule, you have taken out time and you've been so patient. And in the session was extremely interactive with very live examples you have given. I thank you, sir.
Thank you, madam. Thank you very much.
Okay, so I don't find any questions from the chat. So we'll end the session. The quiz link and the feedback link is there in the chat box. You can please give the feedback and get the quiz done. And then I will just to remind you of the day 6, the last day of our workshop tomorrow, where we are going to have light on modern challenges of emerging trends in cybersecurity to deal with real-time threats and the future of cybersecurity in industry by Mr. Lakshmi Kiran Velela, cybersecurity lead in TCS, Bangalore, Karnataka. So I, Arshia, sign off here for today's session. I thank all of the participants for being there. So stay safe and be productive. See you tomorrow. Thank you.